Hello. Welcome to the Turbomachinery YouTube channel. What is rod drop in a reciprocating compressor? Rod drop in a reciprocating compressor is a condition monitoring technique used to measure the vertical wear of piston rider bands. By using proximity probes to track the downward displacement of the piston rod, operators can determine how much the rider bands have worn. Rod drop allowing for scheduled maintenance to prevent catastrophic metal-to-metal contact between the piston and cylinder liner. Reciprocating compressors are critical assets in many different industries including oil and gas, energy production, petrochemical, refrigeration, and many others. They often serve a critical function in the industrial process and are an indispensable part of the production line. Due to the mechanical behavior of reciprocating compressors, they require condition monitoring systems to ensure efficient operation and to provide early fault indicators that can help prevent critical failures and unplanned downtime. A reciprocating compressor functions as a positive displacement machine that increases the pressure of gases by using a crankshaft-driven piston to mechanically reduce the gas volume within a cylinder. It operates through a cycle of intake, compression, and discharge to deliver high-pressure, low-volume gas. The piston moves back and forth within a cylinder. During the backward stroke, the intake valve opens, drawing gas into the chamber. During the forward stroke, the intake valve closes, and the piston reduces the volume, increasing the gas pressure and temperature. The piston rod is what drives the movement of the piston while it is moving through the highly pressurized cylinder chamber. The piston is held in position by components called rider bands. One of the most important mechanical indicators of machine condition to monitor for horizontal reciprocating compressors is the change in displacement of the piston rod relative to its housing over time. In the reliability industry, this is commonly referred to as rod drop measuring. Rider bands or rider rings are a critical part of a reciprocating compressor. They carry the full weight of the piston while it is moving inside the cylinder. The rider band keeps the piston centered to prevent any metal-to-metal contact between the piston and the wall of its housing by carrying the full weight of the piston. Rider bands are designed to wear away over time at a very slow rate. However, imperfect conditions and certain mechanical faults can cause the band to deteriorate faster. It is very difficult to measure the vertical displacement of the piston since it is located within a highly pressurized cylinder. Therefore, measuring the change in the position of the piston's rod is an important mechanical indicator of the condition of the compressor's rider bands. These measurements are usually taken by inductive proximity probe systems. As the band wears down and degrades, the piston's rod will drop further. A reliability professional can set alarm and shutdown levels based on the displacement of the rod from the original 0 point. This will indicate to the operators when to schedule maintenance and when they need to shut down the compressor to prevent the damage that would occur if the piston were to make contact with its housing. Proximity probe that is monitoring the rod drop itself must be mounted perpendicular, 90 degrees angle, under or above the piston rod. Mounting the probe above the piston rod is generally preferred as it reduces the chances of contact with the probe itself. Additionally, a horizontal probe can be mounted 90 degrees away from the vertical probe to measure rod flex. A proximity probe system uses eddy current principles to measure the distance between the face of the probe tip and a conductive metal target object, in this case, the piston rod. As the rod moves toward or away from the sensor, the change in relative position is indicated by a dynamic millivolt signal output from the probe driver proximeter, which can be displayed on a digital monitor and trending the rod's position over time. Since the piston cylinder is a highly pressurized environment, it is very difficult to make direct measurements on the piston. Operators should instead monitor the changes in rod position and use those measurements to extrapolate the absolute position of the piston itself. By using the principles of similar triangles, we can assume that the change in the position of the rod is directly proportional to the relative displacement of the piston due to the degradation of the rider bands. In addition to the proximity probe system monitoring displacement, a second proximity probe should be installed at the drive end of the piston to measure the speed and phase of the rotating element. This allows the displacement reading to be taken at the same time and position in the piston rod cycle, which is necessary to be able to accurately trend data over time due to the deflection at various rod cycle stages. Thank you for watching. Please like and subscribe the channel for more informative videos.